My name is Antoine with a company called Pix4D. We'll be doing about a few minutes of product demonstrations and what Pix4D is about. Very briefly, some of you might not be familiar with Pix4D. We're still a very small company, although we have an established name in photogrammetry and structure for motion. The company is founded in 2011 in Switzerland. We now have a US office as well, doing support and business development. We work with a number of drone manufacturers, and this is really our focus: how to create maps and models out of drone imagery. We do that in a fairly automated manner, so we're really trying to democratize photogrammetry and map making to a large number of people through an automated workflow. At the core is images, and pixels are our input, and we provide different guidance about how to acquire those images. Most of our users are using drones, but some of you guys are using regular camera and tripods, or handheld cameras, or even traditional large format cameras on aircrafts. You can see here we have different flight plans based on what the subject of interest is. We work off a local computer, desktop or laptop. We also have an app, and I'll be developing on that a little bit at the end. And we also have something fairly new, which is our enterprise offering, which allows people to put our photogrammetric engine on the server for those who have a lot of data to process and who want their own customized, scalable solution in the cloud or in their own networks. We serve a number of different industries. Traditionally, surveying and mapping are our core industry. Over the last year, we've been seeing a lot of growth in construction, and mining has been also a very early adopter to structure for motion and drone technology to calculate volumes. We create a number of different outputs and different formats. This is a triangulated, what we call a mesh. Here is a traditional point cloud. You can actually see the points. We can create elevation models, contour lines, index maps for multispectral and hyperspectral imagery. And this is a tool that we have that extracts the terrain from the objects, so traditional feature extraction. We also have a mosaic editor, because we can create a 2D map. A lot of our users want to have a very nice of the mosaic, make some of the cars disappear, and ensure the seam lines are really up to requirement. One of the main features is we can actually perform measurements, 1D, surface, and volumetric measurements inside the software. And a lot of our users are doing that to calculate an area or volume of a stockpile, for instance. You can extract that vector into a shapefile or a CAD format. And of course, you can classify the points that you have. And at the end, we have to create a number of different outputs, because we serve all those different sectors that work with different tools on the back end, if Pix4D is not sufficient for what they do. This is an example of a landfill in Hawaii. You can see they have a number of ground control points, and on the bottom half are surveys at different times of the year. And what this client was really interested about is the change of the time, of the volume, and the accuracy of photogrammetry from images, and also traditional survey through some high-end equipment they were using on the truck. This is a corridor mapping done, so within 24 hours of a flood in Europe, they were able to map the area with a drone and process and deliver the output to the client, who was the government. So very quick turnaround time, thanks to drones that are quickly deployable. We've been doing a lot of our clients doing a lot of vertical surveys, not only to reconstruct a point cloud, but also to be able to inspect. And everything is measurable from the images, because we construct a 3D model. This is a well-known location in Brazil. They've been trying to really make an as-built through laser scanning, and they didn't have enough space to be able to do it. So through drones, we were able to fly very, very closely to the statue and make a point cloud out of it. So very unique. I have about 6 minutes left. We'll continue. What we found is the production of a point cloud is often not enough. What really a lot of people are looking at is inspection and measurement of towers. So for instance, here you can click on any point of the 3D point cloud on the left-hand side. We will highlight all the images where that feature is actually located. And we can display the 2D images on the right-hand side, where very precise measurements can be done. So here, Nest, I have the distance very easily through the photo that is in real time correlated to the 3D point cloud. We've developed a little app that works now on iOS as well as Android. The app is really taking care of the mapping of the drone, because as you understand, the input is very, very important. So we have created an app that would fly the drone and orient the camera in the way that is very conducive to making a good map. And it's been really easy. One of our big takeaways has been that a lot of engineering firms are now using drones as another tool in their toolbox. And they don't want often to be expert pilots, and they would start with a low-cost drone before upgrading to something a little bit more capable. And our app is making things really easy. So at the conclusion, I think what we're seeing is a lot of traditional 2D mapping, site mapping, topo work is also moving to inspection and 3D structures, which is really exciting and also brings its own sets of challenges. UAVs now are, I would say, pretty common now, and a lot of firms are trying to understand really the value and what they can make out of it, integrate that into their workflows. And with the server solution that we have, we're working with a lot of companies who are looking at really larger scale projects where really drones before that were confined to smaller areas. We'll be doing a very quick demo. So basically, you can create a project, you name it. Create a project, you have the images that are JPEGs or TIFFs in your computer that you would say, those are the images I want to use for my model. We will display them. If the images have an EXIF tag with the GPS, it's even better. We don't need to have GPS information. We can do everything from computer vision, but the GPS would help also give a sense of scale and improve the quality of the results and make things faster. For the IMU data, the 3 angles, we can now take them. The advantage is really only a small increase in processing time. So those people who are using it are usually people that have a high-grade IMU from an airplane and flying UltraCams or DMCs. We would simply display the photo centers on this map here from the GPS coordinates. We would create a quality report that has a lot of information about RMS errors, key points, surface covered, processing time, etc., that a lot of surveyors actually have to rely on. You have to understand a lot of professional land surveyors are now using drones as I said, another tool in their GPS and area mapping toolbox. And they need to ensure the quality is good enough because they're putting their stamp on it. We would create very quickly in the field an orthomosaic at 1/7 of the GSD, of the ground sample distance of the image, as well as an elevation ortho. Here is showing the overlap of the images. We require about 80% overlap in between the images to be able to have a strong feature matching. And here you can see the point cloud here in full density. So it's colorized directly from the pixels. We basically do a weighted average between the one feature that is covered in many images and colorizing it in the point cloud. From there, you can actually do any type of measurements on the fly. Here, I'm just selecting a quick area. It's highlighting the volume out of it. And now we have also a new feature where you can actually import a base shapefile for the surface from which you want to do the elevation from. And we would simply highlight directly the results on the screen. So a lot of mines and landfill managers are using that to be able to do surveys a lot more often than what they used to do it with. And also, there's actually less errors over time, and that directly goes into the P&L and balance sheet. So those numbers are really important to them. Here's another mosaic. Elevation models, contour lines, we can create them also in a PDF format in addition to the traditional formats. And very quickly, I have about a minute left. This is our new version. We actually have one in beta, but the public version 2.0 is still available. Here I would simply show the images. You can see they have the slightly different orientation. When you fly things in the drone, it's a light platform, so you would actually see differences in the images. It's not as stable as flying very high. Below that is the point cloud. If you zoom in, you actually see the points. And to calculate the volume is actually, or surface is actually pretty easy. You select a couple points. You have your surface or your vectorized, and you have the numbers here, 151 meters square. And that's pretty much it. My time is up. I have 7 seconds left. We have a booth upstairs next to the elevator. And thank you for your attention. Appreciate it.